Welcome back. We're going to focus on Module 13 today. We have talked about looking at scatter plots. We have looked at linear correlation, or R. We've also created regression equations, but once we've done that, what do? We want to check and see how well we have performed our calculations or how well we have fit our data. So from the Learn by Doing on page 74, the prediction errors, we're going to use this table to show observed and predicted distances for some drivers, and we're going to find the following information. The predicted distance for driver 30, who is age 82, well, in order to do that, we need to use the regression equation, which is modeled by the information here, where we have 576 and -3. So 576 is our y-intercept and -3 is our slope. So for a person who's 82 years of age, we're going to take 576 plus -3 times 82, and that's going to give us 330 feet. So that is the predicted distance of this driver. Now, the error associated with this prediction, notice that the formula for error is to do the observed value minus the predicted value. Well, the observed value was 360. 360 minus 330 is 30 feet. Now, the error in this case is positive because 30 is a positive number. And this tells us that the predicted value is less than the observed value, and therefore the prediction is an underestimate. So what I want to show you is, let's say I have a picture, and I have these dots for the linear regression line, and then I have my regression equation. Now, in your error, you're taking your observed value minus your predicted value. So let's say I have this point right here, okay? That point has an observed value that is above the predicted value. And so it is, since it is above, it's going to have a positive value. So this means that for this scenario right here, my observed value was above my predicted line. And that means that the predicted value is below it, so it's less than the observed value. And because the prediction is below the line, it's an underestimate of the actual value. Now, another thing to note is that there might be a little bit of confusion in one of the pieces of information from page 74, the note of confusion here in the regression equation. There was a question mark. It looked like question mark 8.9 plus 1.05 times the intro course grade. And I believe that should have been a negative. So just FYI, that's what they were looking for there. Okay, now we're going to practice with StatCrunch, and we're going to load the shared data set of movie budgets and box office earnings. And this is actually the first data set you see when you go into load data sets. And we're going to perform a regression equation. So I'm going to pop over to StatCrunch, and I'm going to perform this information or this calculation, and then I will come back to these notes. In StatCrunch, I'm going to click Data, Load Data from a shared data set. And I want the movie budgets and box office, which is the first one that we see. So I'm going to click select on that. And they want us to perform a linear regression analysis. The way that we do this is we click Stat, Regression, Simple Linear, and then we need to tell it what information we're looking for. Now we're looking at investigating the relationship between budget as the explanatory, which means X, budget, and then the Y variable is going to be worldwide gross. And then we click Compute. Here is our regression information and our graph with our equation. I'm going to take this back to our notes. Looking at the scatter plot, we want to record our conclusion about correlation here as well as justifying the information. When we're analyzing this, what type of relationship do we have? Remember, we wanted to talk about strength, form, direction, and outliers. Now, the R value is located on our data that we gathered. It's 0.748. That's strong. We have a strong, and because the regression equation has a positive slope, it's going to be a positive relationship. So we have a strong positive. And remember, we're always talking about linear. Now, are there any outliers that might be of concern? Well, we do see that there's a couple of issues that we might have here or here, they're still within our x variables that might have particular leverage, but there's nothing that's really far outside of our data that we're really concerned about. Recording the regression equation, we have the equation down below, our worldwide gross. Now I'm going to say worldwide gross hat, remember because it's a prediction, is equal to negative 7.117 plus 3.119 budget. Okay. Now we're going to click on a scatter plot for the movie Frozen, and we're going to see our information highlighted and answer some questions about that. So when you go back to StatCrunch, I want you to click on Frozen. Now that I have highlighted this, I can actually go back to my chart, StatCrunch, and look at my data. And notice that the pink point is highlighted for Frozen. That point is above the line that's predicted. So the observed value is above the predicted line, which means it's going to have a positive residual. When we're then asked, will the regression provided be an over or an underestimate? We're going to say that it's an underestimate because this value, the prediction, is below. It was one of these points over here that was above the line. And will the residual be positive or negative? It will be positive because it's the observed value minus the predicted value. Now we're going to click on row 21. They want to know which residual is going to be bigger. When you're looking at this, you're trying to determine which one is further away. Frozen is further away from the line, so Frozen is going to have a bigger residual. The Toy Story will have a smaller residual. What can you say about residuals for a scatter plot with a very, very strong linear relationship? Well, your residuals, if you have a very, very strong linear relationship, remember that your points are all going to be really, really close, or if it is just absolutely strong, then every single point is going to be on the line. All of the residuals will be close to 0, indicating that all of the points are very close to the line.